Hi, welcome to today's video, and today we'll be discussing Coulombs law, and I will be going deep into what it is, how it works, and how is it even found out, right? And I'll also be discussing about the charges, what they are, what are the properties, etc. So I hope you like it. If you do drop in a comment and hit that like button and the subscribe button so that you know when we are putting up the next video again. So first things first, we need to first understand what electric charges are and what their properties are so that we understand Coulombs law better, right? So electric charges, now let's understand what they are. We've all done that experiment of rubbing a balloon on our head and putting it on the wall, right? What is happening over there? It is essentially, what we know now is that there are charges that are transferring from the balloon or our hair to the balloon, and then we are able to put it up on the wall due to those charges, right? But initially we did not know that there were these charges. What we did know that something was getting transferred from here to there, and with several of these experiments with different kinds, we got to know that there are two types of these things that are getting transferred, right? One was named negative, other was named positive, right? And that came in because it was the good and bad side, or the positive and negative side of a numbers line. From there we use the names. So we named these two properties of something that we didn't know. We just knew that there was something that was getting transferred, and there was two types of this transfer that was happening, and we named it positive and negative. And then we got to know that these are charges. Charges are essentially just they are electrically charged bodies which have this property of attracting each other or repelling each other. So that is how we got to know about charges, right? We do not know why they are there, we do not know how they are there, and it's just a beautiful way that nature has created us. But we do know that there are two types of them, positive and negative charges. So first, that was the very important thing. Now second, what are the properties of these charges? So the first thing is, of course, the like charges repel, and unlike charges attract. This is the basic stuff, right? Again, these are all from observations. We do not know the reason of these occurrences. What we know is that they happen. So at the moment we just have to agree to them, but as you go deeper and maybe you get into research and whatnot, maybe you'll answer these questions as to why this happens, right? Because these unanswered questions is what leads us to territories which we don't yet understand. So like charges repel and like charges attract. That means a positive and a negative charge attract each other, but a negative and a negative charge repel each other. Repel means going away from each other. So this is the first property. Second, they are additive. Again, it's part of this only. Additive means these charges can add to each other and neutralize each other. That means if plus Q charge gets added to minus Q charge, the whole will be 0. That means there will be no charge on that body after we do this transfer. So additivity is simply the addition of these charges on a body, right? Similarly, if this was positive charge, the total charge on this body would become 2Q. So this would be the total charge on the body if we added 2 plus Q charges. Third, and this is a very important one, is conservation. Conservation of charges. Conservation of charges essentially means that charges can neither be created nor destroyed, right? What they can do is only transfer from one place to another in a way that the total charge before and after stays conserved. That means if when I am rubbing the balloon, there is no charge getting created. What is happening is some charges from my hair are getting rubbed out and going on to that balloon and sticking to that balloon, right? So that is what conservation is. That means the total charge of the system before we started rubbing and after we started rubbing of the system of my hair and the balloon will be the same. It has to be the same. That is what conservation is about. We have not yet seen anywhere that this law of conservation of charge has been broken so far, right? And it is very similar to conservation of energy because all of these things are kind of connected, but we'll get into that in some later video. So this is extremely important. That means the charge before and after the activity or the process will be conserved in totality. We cannot create or destroy any charges in the process. So very important property, very useful in checking our thought process, if it's going well or not. Next is quantization. Quantization is very simply the effect that all of the charge around us, however big, however small, is made up of this fundamental particle. Just like how everything around us is made up of atoms, this is the charge around us is made up of this fundamental particle called E, fundamental charge called E, and E is essentially 1.6 into 10 to the power minus 19 coulomb, and we'll come to what this is later on, right? So E is the charge on a single electron, and every charge that we see around us, maybe on a bigger body or maybe in a wire, is always a multiple of E. That means everything is made up of multiples of E. All charge is made up of multiples of E. That's what quantization means, right? So this is very important. It's very similar to give you an example of how you can understand this better. Take your laptop or your mobile screen. It is made up of something called pixels. Pixels are these tiny little squares which make up the entire screen that you see in front of you, right? Now that pixel is something that you cannot see by yourself, but you know that it exists for the entire screen. Just that number of pixels have been added up and layered up on top of each other, right? So when Apple says ki retina picture or retina screen, what they are saying is it's the same level of pixels or same level of detail that our eye or our retina can handle. So it's very similar to that, right? So pixels on your screen are very similar to E in terms of charges. So that is what properties of charges are. Now, how does it matter with Coulomb's law, right? All of these are equally important and quite important to understand before we go to Coulomb's law, because they essentially make up the Coulomb's law. Now, what is Coulomb's law? Simply, it is very similar to gravitation, which is F is equals to K Q1 Q2 upon R square. This is what was given by Coulomb. Coulomb's law states that the force between two charged objects or particles is directly proportional to the product between the two charges and inversely proportional to the distance, the square of distance between them, right? And this was totally found out experimentally. That means